Hello everyone. So continuing the DSA challenge that we took, today is going to be our day 34 of the challenge, and the question that we're going to solve today is palindrome linked list. You already know how what a palindrome is. So if you don't know, I'll obviously tell you. But yeah, in a linked list, it's kind of a little bit different. But see, here the question is saying easy. So I'm sure by this you can understand that yes, it is an easy problem. So yeah, given the head of a single linked list, return true if it is a palindrome or false otherwise, right? And let's see what a palindrome is. Palindrome is a sequence that reads the same forwards and backwards. Okay, so very simple thing. Just a second. Yeah. So okay, if I write a string N A M A N, right? So if this is a string, right? This and this matches, this and this matches, this and this matches, right? So if you read it from behind, then also it says Naman. If you read it from front, then also it is Naman. Similarly, if you have an array, 1, 2, 3, 2, 1, right? 1, 2, 3, 2, 1. From this side, if you say, from this side also, it is the same thing, right? This is a palindrome, right? But in a linked list, to solve this question, so if you are given an array, right? If you are given an array, 1, 2, 3, 2, 1. If this is your array, let's just say array, what will be its reverse? Reverse also will be 1, 2, 3, 2, 1. Correct? If array is equal to reverse, right? I mean, obviously you will have to compare the values and not the array itself because again, because of the memory allocations and everything. If you compare the values of array and reverse and they are found to be equal, if this is equal to this is equal to this, and so on, right? If this is equal, then you have to return a true or else you have to return a false. What if here was 4, right? So here was also 4. So 4 is not equal to 2, right? In that case, you can return a false. True. So we kind of have an intuition that, hey, I'll have to reverse things. I'll have to reverse the things so that to have an answer. Okay. So let's see the brute force, the naive approach. Right. Naive. Great. So we are given, let's just say if I copy this and paste it somewhere here, right? If this is a linked list that is given to you, right? What will be your intuition? You will be saying that, hey, what if I store it somewhere, right? What if I store it in a stack or something, right? Why am I saying stack? You will get to know, right? You will understand it as you go down to the approach. Okay. So using a stack, right? In in JavaScript particularly, we don't have anything called stack because our array is what do you call is kind of a stack only. And if you push everything from the front, like you say array.unshift, that means you're using it as a queue. So we don't have a concept called stack and queues in JavaScript. We only have arrays that are dynamic in nature, so you can obviously play around with it. So okay, but in general terms, to understand the pseudo code or you to understand the algorithm, you understand what a stack is. Stack is last in, first out. Whatever you put the last will come out as first, right? So traversing, let's just say this is my temporary, this is my head, right? So first value 1, second value temp goes here, so second value is 2, then comes again 2 because temp will come here, then temp goes here and it comes 1, right? Okay, cool. I'll do one thing, right? I'll say that, hey, temp, again you bring be back to the head, right? Now I have the values in my stack. I'll check if my stack dot top is equal to my node's value, right? If this is true, if this is true, then to it's fine. Then to it's fine that hey, I can remove this and I've traversed this, so I'll come here. Then this is also true. Then this goes here. 2 is equal to 2. Yes, again, true. Temp comes here. This is also true, right? So this is a true situation. But what if here was a 4? That means somewhere here you would have your 4, right? And as soon as you come here, you will notice that, hey, this is not equal. This is not equal. That means you will return a false, right? Cool. So pseudocode is very easy. So I won't even write it for you because it's genuinely very easy. But let's discuss the time complexity, right? And if you have been following me till this point, till day 34, you would obviously notice that writing this is very easy. And also, to just to tell you guys, this SD sheet is right. If you can, hover over it, and you will notice that this is for anyone who knows DSA. So I'm sure people who do know DSA will be able to write this pseudocode themselves. So O of n for putting all values in stack, correct? Plus an O of n for traversing and searching, for traversing and finding out if the value exists. So O of 2n will be the time complexity. Space complexity, we are saving every element. So O of n, the interview will say that hey, I don't want you to use any extra space. I want you to do everything whatever is there in the linked list only. I don't want you to do anything, take all the values to a stack or a array and then perform the action. I just want you to do everything on the linked list only. We'll say okay, no problem. We'll just print it over here again, and I will say that hey, sorry, I will say that hey, okay, do one thing, do one thing. My head is here. I'll put my temp over here. Okay. If you remember, when we were discussing this question, I said something called as reverse, right? We were discussing everything upon reversing only. What if I reverse this whole linked list? What if I reverse this whole linked list, right? So if I reverse this whole linked list, don't you think I'll have to create another set of linked lists, right? Another set of linked lists. Now, why is it so? Why is it so? Because if I reverse everything from this thing only, if I say this, and this, then I am playing around with my first input given, right? First given input. And if I don't have anything to compare the reverse with, what will I do? So I'll have to obviously create a different set of it. So that will again take me O of n space, but that is something that I have already discarded, over here, right? Over here. That means I'll have to think something else. I'll have to think something else. Now, what is that something else? See, if I write simple n a m a n numen, right? So 0, 1, 2, 3, 4, right? What is the length of it? Length is 5. What is the mid of it? So if you take the mid and take the floor value, you will get 2. That means mid is somewhere here. That means all the values in the left portion and in the right portion of the mid should be equal. Should be equal, right? As in equal, as in their value should be palindromic. So if n is at the first position, that means it should be at the last position as well. Great. If a is at the second position, it should be at the second last position as well. So that means this is true. That means I'm kind of reversing something from the end in the second half of my list, or in my you can take any data structure, I am reversing kind of my second half. I'm kind of reversing second half. So what if I have a 1 here, I have a 2 here, right? I have a 2 here, and I have a 1 here. This is pointing to null. What if this is my half, right? Somewhere here. What if I reverse this and this remains same? So, and then I can obviously now this becomes this, what should I take? I should take white, right? This should become 1, this should become 2. And if I compare 1 with 1, that is true. If I compare 2 with 2, it is also correct, right? So now I kind of know that I have to reverse the middle part of it. So from mid to the end. Okay, the second half basically. Now how will I do that? I'll have to find the mid. Do you remember how we found the mid, right? We use the slow, fast pointer approach, right? Pointer approach. But also you need to understand something. If I have 1, 2, 2, 1, the length of this is an even length. And if you remember in this approach, the finding the mid one, we always got this. We always got the second element, right? So if my slow is here, fast is also here, slow moves here, fast moves here, slow moves here, fast moves to null, right? And this is what I returned. This is what I returned. That means my second point is the thing that I need to return. But if I return this, then I will obviously have some problems. That means I need to find the first argument. Okay, given, okay, in even I can understand that, okay, you have to have this value. You have to have this value. But what if I am given something like this? 1, 2, 1, right? This is pointing to null. What will I get? I will get this, right? Then I have to reverse this part. I'll have to give its reference as well, so that it, after everything, it joins to this thing. It joins to this thing. So that is why I will say that, hey, if my fast dot next is not equal to null, and my fast dot next is not equal to null. Now, why am I saying dot next dot next? If you notice in this position carefully, my slow and fast was here, slow moves here, fast moves here. This is what I wanted to return. This is the two that I wanted to return, right? This is what I wanted to return. That means that, hey, I need this value. So my fast dot next, that is this dot next is null, right? Is dot next will be null. So that is why this situation came. Cool. This situation came. Okay. Now I have given 1, 2, 3, 2, 1. Okay. And my slow is here, fast is here. So slow comes here, fast goes here. Slow goes here, fast goes here. That means fast dot next should also not be equal to null. We tested this out. That means I'll stop here. This is my mid. This is my mid. That means I need to reverse this portion. Now, why is it so? Why is it so? I won't compare this value, because this value will at the end be compared with itself only, right? With it will be compared with itself only. So no need to return. I need to return this part. That means I need to reverse slow dot next as head. This will be my head of the second half's linked list, of the second half's linked list. Okay. So if I do that, that means my value is looking like this. So what is it now? 1 comma 2. Do you think this 3 will be pointing to this thing? If you are, then you are wrong. Then you are wrong. This is not this. This will be connected to 2 only. This slow is always pointing to 2 only. I am not tampering it, right? I am not tampering it. So this is what it is, right? If I now put my first pointer here and my second pointer somewhere here, right? And I compare the values. Is first equal to second? If yes, then I'll move forward. In this situation, yes, it is. So first comes here, second comes here, right? These are also true. These are also true. So first comes here, second goes to null. This is null only, right? This is null only. So sorry, this is null. Not this, but understand this. This two is pointing to null. Sorry, why did I even make this? Yeah. So this is slow pointing to null, and my first is at 3. If my second pointer is at null, that means I'll have to say that, hey, I am I've you know um what do you call, I have compared every value and understand this, that every value has given me true. That means your situation is a palindromic linked list. Your situation is a palindromic one, right? if if I found any situation in the second half would have not been equal, if any element in the second half would have not been equal to the first half's element, then I would have returned false. Be assured of that. Okay. How will we write the pseudocode for it? Right? Let's try to write the pseudocode. Pseudocode. I'll say that, hey, let slow is equals to you know uh for find first half will be find the mid, right? I will say that, hey, slow, you become to head. Fast also, you also become head right now. While my fast dot next is not equal to null, and my fast dot next is not equal to null, then I will run this. I will say that, hey, slow, you move to next. Fast, you please move to 2 points. So that is dot next dot next. I am kind of assured that I have my mid. What will be my mid? It will be nothing but slow dot next, correct? That means this is the part where this is my head, mid head, right? Or second half head, right? Then I can obviously say that, hey, please reverse this second half head, right? I can obviously reverse it. Now that I've reversed it, right? Now that I've reversed it, what do you think will be my next part? So my next part is to compare the values of first and second half, correct? So let first be equal to head and second, and this is my reverse will give me a head, right? Will give me return me a head. So let second is equal to this. So I already have second and my first is head, right? Okay. So if I have both the values, if I have both the pointers, then I just have to do that. Hey, while my second is not equal to null, because second is at the second portion of the linked list, right? That means it will first reach the null. For example, for sure, I'll say that if my first dot val is not equal to second dot val, I'll just return a false. Else I'll say that, hey, first you move to your next pointer, first dot next. Second, you also move to your second pointer. You also move to your next pointer, right? And if this loop has been done, that means I'll have to return a true. That means I'll have to return a true because I've tested all the situations and my second is at null. And I know that, hey, I have tested all the values, I've tested all the elements, and I couldn't find a falsy value because if I had, I would have returned false already. But there is something that is a good practice. That is a good practice, right? Now, what is that good practice? Let's just remove this false for now. Now, that good practice is that whenever you return a false, you have to re-evaluate. Basically, you just have to reverse your whole linked list again. Now, why is it so? See, in an interview, right? When you are sitting in front of an interview, your interview might tell you that, hey, you have tampered the linked list. I didn't want you to, uh, change the sequence of my linked list. Then I'll say that, okay, reverse my second half head again and then return a false because I want to keep my linked list same as what I got in the input. Okay. And here also I will say that, hey, reverse second half head. I don't want you to just tamper the whole linked list. So this thing is important. This thing is important for interview purposes. You can always mention that, hey, I have, I have, created the original. This is now, I have created my linked list that I obviously tampered for my algorithm. I've now converted it to my original one. So it all, if you somewhere here return the head, you will again find that it is 1221 only and not 1212, right? Okay. So let's analyze the time complexity as well, right? That is also important. That is also important, right? I am finding the mid. That means I am traversing O of n by 2, right? Till the half of it. Okay. I will reverse it. I will reverse the half of it. That means O of n by 2 again. Okay. Here I am traversing the whole, basically every value in the first half as well, in the second half as well. That means this also takes O of n. This complete thing takes O of n, including the reverse and everything. This at all in all takes O of n. That means this time complexity has been boiled down to O of 2n. N by 2 plus n by 2 is O of n only. So this O of n and this O of n, that means O of 2n, and space complexity. No space, no extra space, right? Let's now try to write the code. So I'll say that, hey, let slow is equals to head, fast, you also become equal to head right now. So while my fast dot next is not equal to null, and my fast dot next is also not equal to null, then in that case, I will say that, hey, slow, you move 1 point ahead. Fast, you move 2 points ahead. Fast dot next, right? That means my, uh, here I can write finding the mid. My mid is nothing but slow dot next. So I can say that, hey, let let my second pointer is equal to reverse linked list slow dot next, passing the head of it. Let first is equal to head, and then I can uh, compare the values of first and second halves, right? So while my second is not equal to null, that means I'll have to check that if my first dot val is not equal to my second dot val, I can say that, hey, please reverse ll of slow dot next again, because I want to bring it back to the original linked list, right? And I will say I can name it as second only, not, I mean, I hope you understand, right? And I can say that, hey, return a false. If this is not the condition, then please move first to its next position, dot next, second also to its second dot next. And if this is true, then again reverse the slow dot next and return a true, because I think that, hey, my value is true. Let's quickly write down the reverse function as well. Function reverse ll, which have a head. Let's say that, hey, temp, you become equal to head, while my temp is not equal to null, double equal. I'll say that, hey, I'll create a previous value as well, which will be pointing to my null. I will say that, hey, next, you are nothing but temp dot next. I have to save the next value as well, if you remember. See, I'm not going to explain you how reverse works because I've already created a video. You can go and check it out. And I will say that my temp dot next, you become equal to priv. My uh, my priv is now equal to temp, and my temp is equal to next, and I can return the priv value as the head. Let's try to run this. Accepted. Great. In the first go. Wow. Submit. Great. Accepted. Right? So yeah, this was the pseudo code. Obviously, it was an easy question, so you don't have to, think more about it. Find the mid where for even length, find the mid as the first mid and not the second. So, okay, yeah, this is my first hint. Second hint could be reverse the second half. Third, compare values from first and second, and return true if found, return false if any value doesn't match. Brownie points. If you reverse back the linked list, the second half again to bring back the original given input, then it is good, right? So let's mark this as done, right? And by this we have done our day 34 as well. Thank you so much, guys, for joining in. I'll see you tomorrow with the question called find the starting point of the loop in a linked list, right? So yeah, thank you so much. Bye bye.